Good morning to everyone. Thanks for joining us today. Today we're doing our Mastercam 2024 new feature breakdown. The first thing I want to talk about is how to find the new features for Mastercam 2024. And there are three ways to do this. It's just like last year. We can find the What's New browser through Mastercam in the Help tab. We can go to what'snew.mastercam.com, or we can use the PDF alternative. Now, if you're interested in using the PDF, then you go ahead and go to the handouts in Demio, and no handouts have been shared yet. Let's see, here we go. There we go. So I've just added the What's New PDF to the handouts. You can go there and download that if you like, if you prefer to use that instead of a browser window or something. And that's a file that you can keep on your system. All right. And when we go through this, basically to find the feature that we're talking about, I'm going to mention the title of the update. You can use Control F on your keyboard to open the search function, and then you can just type it in. It should bring you right to the page. So with that, let's go ahead and get it opened. So if we're taking a look in Mastercam and we go up to the File tab, we can go down to Help on the left-hand side and then click on What's New at the top of that list. That's going to open a new browser window, which mine came on a different screen, so I'm moving it over. And here's the What's New. This looks just like last year. Now, this is in a browser tab. However, this is actually a local document. You can tell from the address in the URL up here. This is coming from a local file. So that's kind of nice. It's just a browser version of the new features, and it's really easy to use because of the navigation, the interface. It's really nice. Now, if you don't have Mastercam 2024 installed, you can open up a tab on a browser and you can go to what'snew.mastercam.com. And that's also going to bring you to the new features. However, this year, the formatting for the What's New online is different than the one that comes with the software. However, it still is basically doing the same thing here, where you can kind of go through the individual groups and you can pick off what you want to see. So if I want to look at, updates to notes, now I can see my note workflow improvement. So with that said, we're going to go ahead and get started here. And I've marked every one of mine with a bookmark. So I'm just going to be going down the list here. So the first one is controlling your graphics view with the Gview cube. So we have a new on-screen entity for Mastercam 2024 called the Gview cube. And this little cube helps us do so much in terms of the viewing of our parts in Mastercam. So let's just jump over to Mastercam and take a look. Actually, I have two windows here. There we go. So our Gview cube is in the lower left-hand corner. It's right inside of or nestled within the dynamic gnomon that we use for dynamic plane creation. And it's written on there what the names of those planes are. And what's really cool is that, if let's say I'm using my motion controller for a second here, as I move around on screen, the cube will move with the part and it's staying oriented correctly to the planes. And if I want to go to a specific view, I can just click on that face of the cube. So I can click on top and that takes me directly to a top view. Now, sure, you can do that by going up to your view tab and then going to top, but now I have to go farther away from my part. I have to potentially open a different tab to get to that. We also have the right click option, but that also adds another click. So this is a quick on-screen way that's really close to your part that gets you to the view that you want. But more importantly than being able to get to existing views, we now have access to new views. Where we started in this file was actually here at isometric reverse. And if you just click on the corner, it takes you to that view. And you also get access to views that we didn't have before. If you click on the piece between top and front, I get a top front view or a top right view, or you can also get top right back. So that's three completely new views right there. And there's even more than that. So I really like this for giving us the new views of things that we've, mentally have thought, oh, maybe I just want that particular view. Now it's right there. Additionally, if you click and drag from the faces, you get some kind of dynamic movement from the center of the models. from wherever your viewing is. If you click and drag from one of these two view bars, like right back, then you get a rotation around an axis like this. So that's also pretty useful. And we also have buttons here that can do panning if we click on them, or an alt click gives a rotation. Also works for up and down and rotating like that. The amount of rotation is defined by the settings, which we'll take a look at in just a second. And we have this button down here. This can do a full 180-degree rotation with a click. Or there's several other keyboard shortcut commands we can use to make it do other things like shift click, shift alt click, or control alt click. Now, it's not expected for you to remember all of that, which is why a pop-up exists. If you take your mouse and just leave it there, it'll give you the pop-up and tell you, what you can do with that button. I have a feeling that really just being able to click on things like this to quickly get to views is going to be all I really want this for. That, and also having a visual representation of which plane I am looking at. I see that this actually says top, and mentally, for me, this is a little easier than looking at these colored arrows on the gnomon and trying to orient my headspace where I'm at. I can just see exactly what I'm looking at. I think that's pretty helpful. Now there's a couple other things to go over here. If we right click on the cube, we have the option to go down to settings. And in the settings, we can change the text size on the cube. You can change the gnomon and cube size itself. Mine's a bit bumped up from default. I like it a little bit bigger. I think it's nicer for showing other people what it looks like. And you can change the opacity. Additionally, the rotation that we got from alt-clicking these arrow buttons here, you can change the increment of that rotation with this field here. And finally, the last thing that's really cool about this is the way that it works with your WCS. So if we right click, the default behavior has this relative to your current WCS. So that means that if I move my WCS to top, my top is now here, right? And then as I shift it around, my cube will reorient itself based on that. I find this really helpful if I'm doing, say, I'm going to click on that and Alt-E. So now I'm just dealing with this one part. And let's say I create a new plane. It's going to be on that face and centered here. I'm going to call this Op1. That's setting as my WCS. And now my cube's just ready to go. And when I go to do Op2, I flip it over, I put it on this face, swing this around by 180 degrees. Set that there, call this Op2. Now my cube's ready to go for that. So it's really nice. I like that this basically just follows whatever you're doing in Mastercam and makes it a little bit easier to use. And easy to keep track of exactly what you're working on.
That is such a cool update. I love that Gview cube.
Yeah. Yeah.
It's my new mascot. It's my spirit animal.
Right? When I did the shuffle for what we were going to cover in the webinars today, I decided that this had to be the first thing. I actually overrode the shuffle because I wanted this to be the first thing we talk about, just because it's so neat. So who is this for? Well, I think it's for everyone. I think that everyone could use this, but really I think this will mostly impact people who don't already have a motion controller, because it gives them the ability to click on these views to get where they need to go, rather than being dependent on a motion controller like we use here. So, I mean, that is for people who travel a lot. Maybe they're on a laptop and they travel, don't want to carry a 3D controller because it's bulky, takes up room in the bag. Or schools. A lot of schools don't have the 3D controllers in their CAM classes. So this is a good solution for that. But really, for myself, I really just like that it shows me what I'm looking at here. I think that that's great on its own. And I'm going to use it a lot as a reference tool. So next up, if we take a look in here, we're going to go to Dynamic OptiRough Improvements. This page is very short and simple, and it seems like not a very big deal. It has changed the way that the helix starts for a dynamic OptiRough toolpath. But this does make a pretty significant difference when we're looking at things like cycle time and efficiency. So let's go ahead and open that up. I'm going to use my fancy tool here, actually. There we go. So let's take a look at this part here. I've got a few operations. Here's my starting stock. And then I have my first OptiRough. That leaves me at about this point here. And then I'm going to use my OptiRest toolpath to get the majority of the material out. And that leaves me here. I'm pretty good, but I'd like to take out a little bit more material between these fins. So I've got another OptiRest toolpath here to mill that out. And it's doing a pretty good job here. But let's take a look at this entry helix. Notice how tall it is. And if we compare this with our stock model, it doesn't really make sense for our entry motion to be so high. It's much more than is really needed to get in there and do a good job. Taking a look at operation 6, you might notice that this is actually locked here. It's got the little lock icon, and that's because this was created in Mastercam 2023. So now taking a look at operation 7, let's go back to 6 for a second. So we notice how tall this is. And then if we go down to 7, this is the exact same toolpath, just with a better algorithm for calculating that helix in movement. So it's much shorter. And this provides us with a much more succinct and efficient toolpath. So if we take this, and I'm going to put it into verify just to get an idea of the cycle time. I know it's not always perfect, but we can get an idea of it, and we can at least use it as a reference. We're looking at 12 minutes and 32 seconds versus if we open up number 7, this says 12 minutes 25. Now I bet that's probably not as good as it actually is in terms of improvement. I bet the improvement's more than that, just because you can see the big difference in the number of actual helix, spires going down. So I do like this improvement a lot. And the other thing to note here is that this still looks kind of high, right? But that's because in the parameters, this is still using the default for the 125Z clearance. So if we go down to operation 8, this one has a much shorter clearance at just 50 thousandths. And that's a nice tight helix. It's just going to get us right in there and start milling. As we look at this stock model, it does need to helix in a little bit because there is some area here that it's going to be chewing into. So that's why you still got some, but I think that that's a great improvement to the way that the helix is coming in for OptiRough. And that gets us this result here, which is looking great and ready for some finishing. We're going to be doing detecting undercut stock when machining. That's the next thing that we're covering here. So the update here is that the Waterline toolpath now has a checkbox that we saw in Opti last year, and that is the detect stock breakthrough. I think this actually had a different name. I think it was detect undercut stock. Oh yes, right here it says renamed from detect undercut stock to detect stock breakthrough. And that was just to clarify it a little bit. So if you've used this in Opti, then you might already be familiar with what we're about to cover here, but we want to cover it anyways to kind of show you a cool implementation of this new feature. I'll be switching units throughout the day here, so we're going to millimeters now. All right, so we're going to start this with a cylindrical piece of stock, and I'm going to use an OptiRest toolpath to rough it down to get to a point that looks kind of like this. And let's assume that we're doing this on, say, a vertical with a rotary or something like that, and we're just going to turn it over and do the next side. So on the next side, we would get an operation that looks like that, and we would get a similar stock model, but it's all, it's removed the rest of that stock. So now we have something that's pretty closely resembling the shape. So at this point, if I wanted to add a Waterline toolpath to start cleaning this up, we would run into a bit of a problem. Because the Waterline toolpath, even though it has the stock turned on and it's looking at that particular stock model, what it's basically seeing is the silhouette as the maximum size to cut, and then it sees that there is still stock all the way down here, so it's just running the entire toolpath to that depth. So what we need to do is turn on the option for detect stock breakthrough. And when we do that, this is going to shorten the toolpath to where it only will cut where it sees that it can actually hit material based on that breakthrough. So you can see here that it's cut the toolpath much shorter, but it's also not level. And that's by design. One thing that you might be thinking here is, well, what's the point, right? I can just use steep shallow. Steep shallow will prevent a problem like this. Well, that's true in a way, but consider this. What if I was using something like an accelerated finishing tool? Maybe I had an oval form tool. If I have an oval form, I don't necessarily want to limit everything by a Z depth, because the widest part of my tool where I'm cutting, it's going to have a contact point that's much higher up from the tip. And if I'm limiting it by a certain Z depth, then I'm basically having to guess at how far beyond this midline I want to go with that tool to get it to cut up. And it's also going to continue to do extra work where it doesn't need to, because there's no contact in some areas. So it kind of brings us back to where we were before I even turned this option on, right? Where it's cutting extra. So this is a more efficient way to reduce the amount of depth cutting that's happening with this toolpath and be able to accommodate for those other types of tools. So I really like that. One thing that you'll notice is that it does go really far right here. And, maybe that's a bit extreme, but, you can use this in combination with limiting. So if you think that it's done mostly a good job, but maybe this section's a little bit too much, you can turn your steep shallow back on and you can trim it up a little bit if that's helpful for you. But this is still going to be more efficient than using a steep shallow for the entire toolpath to keep everything at a specific height. We do have a new Mastercam simulator workflow for mill and router machines. So essentially what has happened here is the simulator options button, which is the button just to the right of verify, has been deprecated because there are new options within the machine group setup that will cover everything that was done in that panel. So if you click on that button, it's just going to take you to the simulation page of machine group setup instead. And then you can set your options accordingly. So everything that you found in the simulator options is now found somewhere on either the stock setup page or the work holding page or the simulation page. This does also give us an option to use something called stock override. So this way we can actually manually tell simulation what we want to see as stock rather than being stuck with only the starting stock and having to run every operation every time. All right, so here's the part that I'm going to be working on. And if we take a look at the files here, we're going to go into the stock page, and I don't have anything selected yet. So I'm going to go ahead and select something. You might notice that this page is now different. So we now have new options for selecting our stock. Back by popular demand, we have add from two corners. So if you just want to do it that way, there you go. There's your two corner option, and that's back. We also have a rectangular and cylindrical option. Now, when you use these options, and I'm going to use rectangular here, you're still going to click on your part, and then it's going to basically create the minimum size rectangle or cylinder around that part. So you can also adjust the size of it by clicking and dragging, so you can do this just like a bounding box. Now, if we're doing everything just like bounding box, why don't we just use the bounding box option? The main difference is that when you're using bounding box, you have a little bit more control in terms of the construction plane from which that's being created, and it has the ability to create geometry and save it to a level. Whereas when you're using rectangular or cylindrical options here, this only sets up the stock for Mastercam. It will not create an object. So with all that set in the stock page, let's go to the work holding page. We can see that I do have a fixture selected. It's on a level that's not currently visible. And then we have a simulation page here. And I have an option here for stock override, which allows me to pick either a stock model that's already in the file, a different file, or I can select something on screen. And that gives me all of the different options that we saw in simulator options before. So with that, if I go to the machine tab and I just have my helix bore selected and I go to simulate this, what I should get is my fixture and my stock model that was chosen in the stock override for simulation. And there we go, running really nicely. So this also plays into something else that's kind of interesting. And we'll see how this behaves, because I had some fun setting this up previously. When we go here, and let's say I turn off the stock override. So right now, if I were to take, these two operations and just send them to verify, this should pull in my normal stock, right? And maybe that's not loading that stock in quite where I need it to. Let's see, I'm going to turn on the fixture. Okay. I'm going to reset my stock here because it should actually be from two corners. Look at that. I'm going to use two corners, something I haven't done in years. Look at that. Beautiful. Okay. So if I send this to verify, it should have popped up. Didn't update. Okay. Oh, here we go. Rectangular 2. Let's see. Let's remove that. There we go. Yeah, the multiple stock option kind of bit me there. There we go. All right, so that's for the first part. First couple of operations, looking pretty good there. Now, at this point, if I wanted to simulate just the helix bore, I don't want to have to simulate everything through these operations again, because this OptiRough takes a while, right? If I wanted to run the stock model in for verify, I don't want to have to go into the settings and go set that as my override. What I can actually do is just make sure that I have that selected as the first operation, and then select anything below it that I want to add. When I click verify, it should automatically take that stock model and load it in as my stock. I love this update. This is awesome. I think that this is one of the, what I would call, intuitive updates to Mastercam. Once you understand that you can do this and you've done it a few times, this is going to get ingrained in your brain. You're going to remember that this is how you do it, and you're going to forget that this was ever a new feature. This feels like something that's been around for a long time. So I absolutely love that. Just make sure it's the first thing in your chain of any toolpath you want to simulate, and then click on verify, brings it right in. If I were to select the whole group like this and go to verify, it is not going to pull in that stock model. It has to be the first thing that is selected. So if anything else is selected above it, then it won't work that way. So that's a little bit on how the new machine group setup is working with the simulator options. So again, using simulator options here, that takes you right back to your simulation page. And any components that you would find in that simulator options panel is now either in here, or it's in the work holding page or the stock page. And we have our new stock options. Alrighty, so that's it for the updates here. Now I do want to point out real quick that this is only for mill and router. So if you're on lathe, wire, anything like that, it is not going to affect you in that way. All right.
Yeah, positive feedback from those updates there, John.
Oh, that's good. Excellent.
Adding two corners back in, as well as the stock the stock model.
Yeah,
being pulled into verify.
Yeah, I think that both of those are probably good updates to have. You know, I never really have a need for the two corners except for what I just did today. But I know that there's a lot of good uses for that, especially in router. So glad to see that back. And the other options for rectangular and cylindrical, those are nice. I'm someone who would prefer to use bounding box just because it allows me to create a solid. And then I have that to also reference and chain off of, which I like. But everyone kind of has their own way of doing things, and depending on what you're doing, you may not need that. It may not matter to you. But I think that this kind of gives everyone a way to do what they want to do in a way that is effective for them.
Yeah, and the two corners option was always sort of there. You just have to bounding box it, but then there's more clicks. And for people that had a nice workflow of wireframe entities, and just having that button right there reduces the amount of clicks you need to go through to set up your stock. So I'm glad they have that back end.
Right, exactly. All right, so the next thing is working with content files. So this one, I don't have a lot to show you on this. I really don't even have a file to run or anything like that. Let's just kind of talk about what this means, because it does affect you as a customer, but it also affects us in terms of support. So the first thing is that content files, if you're not familiar, content files are special zipped files that we send out typically to our customers who are ordering, let's say, a post. When you order a post, rather than having to take each individual piece, your machine definition, your control definition, your actual post file, PSB files, DAT files, all that kind of stuff, instead of doing all of that individually, putting them where they need to go, it's one file that you drag and drop onto the Mastercam screen, and it instantly installs everything where it needs to go. Super awesome. Way, way easier. Love it. So what the updates that we have for this year include the fact that content files, they are version specific. And if a content file is from an older version of Mastercam within the last 3 years, if you bring it into 2024, it will automatically update itself. So that's pretty nice, because let's say that, last year we delivered a post to you and you still have that content file, and now you've added another computer with Mastercam, and you're on a network license, so you can just add them as you please. If you need to get stuff installed, but you don't have the 2024 version, but you have 2023, just install that, and it will install it while migrating it up to the current version. Now, we have had some reports of this not working perfectly, so give it a try, see how it works, and if it's causing a problem, let us know, and I'm sure that there's ways that we can help you, or we can try a manual migration or something like that. But in the couple of times that I've used it, it does seem to work, so I would say definitely try it, and then we'll go from there. Jeff, did you have other thoughts on that?
Nothing to add to it. This is really a nice change for someone like me who deals with a lot of different posts from customers, and I'm often working in the latest version of Mastercam. So our archive of posts may be not up to date. So it's nice to just be able to drag and drop a content file in and have it migrated up.
Right. Absolutely. So additionally, content files will now have the ability to open PDF files. So there may be a case where we need to give you some more specific information about your machine in the install. So we can just include that as a PDF. And when you go to install it, by default, it will actually ask you if you would like to open the PDF file. It'll just bring up a little pop-up window. You can click yes, and then it brings up the PDF. If you want to turn that function off for the prompting, if you want it to just do it automatically, you can go into your configuration, and then under files, there's a new checkbox for prompt to open PDFs. Just uncheck that, and then it will do it automatically. And then finally, the last update for this is that when you run a content file, if it contains any config or workspace files, which is essentially everything that can customize Mastercam, it will give you an option on whether or not you want to do those files. And so that's good, because, let's say that you made a content file and you try to send it to someone else so that they can, run the same thing as you are. But if they don't want your configuration, if they just load that content file, the defaults by which you make a content file would include those files. So they would load it, and all of a sudden their computer looks completely different and they don't like it. So this gives you a little bit more power and flexibility over how you install your content files. But when you get them from us, as far as like a post install, it's not going to contain that. The only time we might do that is if we're working on something specific that has to do with your config or workspace files. I don't even know what that actually looks like. It's just mentally, that's my train of thought on it. So maybe you'll see that at some point if you have a certain support issue. All right, so the next one is really cool. This is going to be collision checking for Blade Expert. Now, you may not be a Blade Expert user, but if you're ever making like impellers or something, if you don't have Blade Expert, you should really consider it. And if you don't have it, maybe this will be enough to convince you. If you already have it, you're going to be pretty excited about this next update. So there is a new checkbox within the tool axis control page that basically allows you to get more access into your part just by turning it on. This will increase your calculation time, and it's, it takes a bit of a system to actually run something like this, but this is really helpful when you have reduced clearance or big holders for your tools. All right, so Blade Expert, basically what I'm doing right now is I'm finishing the hub, right? So we're looking at kind of the floor that's between each of these blades, and that's what I'm trying to finish. And you can see how out of this section, we're basically looking between these three blades. One of those sections finishes up pretty well, but one of them really doesn't. It's not getting up into here. And if we take a look at the back plot, turn our holder on and turn the quick verify off for a second here. So what's happening is as it's coming along, it basically is getting as far as it can, and then it's retracting because the holder is getting in the way. And so this really limits us on how far in we can finish this floor. So going into the parameters, under tool axis control, it's just a checkbox here for use full collision check. I'll go ahead and let this generate, and it's done. And you can now see that we have motion that goes all the way up there. Looking at this in backplot, that first section is basically the same. The second section, the way that this is working, and I'm going to step through this so we can really see it. It's going to come in, it's going to get up to, that's about where it was quitting before. And it's going to just tilt the tool much more aggressively as it needs to get up into that floor. I mean, you can see how aggressively this is going to tilt. It's really going to get in there. And it's going to rotate anything in any direction it needs to make sure that it continues to have access. It's still collision checking. It's not going to run into anything. You still have good clearance there. But yeah, that's how you're going to get more access into those floors, by just using a checkbox. So why would you leave this off? Well, this does increase the time it takes to actually generate the toolpath. So I would say this is going to be design dependent. And depending on your particular designs, you might decide whether or not this is a good thing to have on by default. If your parts are all generally coming out without the need for this and you only need it sometimes, leave it off. If the opposite, you need it pretty much all the time, then set that as part of your default. And that can help you. But just do keep in mind that the increased generation time is a factor. All right. It's really a simple demo. I don't really have anything else to say about it, but yeah, if you're making anything like this, if you don't have Blade Expert, this is what you need. I mean, just the ability to rough out and then actually finish something like this with dedicated toolpaths is really awesome. If you're interested in using something like this, make sure to give our sales team a holler. You can email them at sales@mcamnw.com and we can set up a demo for you. All right, so next up is one of the really big changes, and that's going to be the B-axis contour turning enhancements. There are 3 major changes for this, and I think that all 3 of them have a good place for this toolpath, and I think that for anyone who's using a B-axis contour, this is going to be a big difference. Now, if you're not familiar with B-axis contour, essentially what this can do is look at your part, and while you're turning, if you have a rotating B-axis head, it can rotate that head as it goes along the cut. And this can give you more access into areas that are tight. It can improve your cut motion depending on the geometry that you're dealing with. It's a nice way to manage your turning when you're dealing with odd shapes in a mill turn environment. So the 3 updates for this year is the ability to edit your vectors, the ability to manually adjust your usable insert area, so what parts of your insert can actually do the cutting, and the ability to adjust stock. So we're going to cover all 3 of these, but in reverse order. All right, so here's the part that we're making. What I'm going to do is I'm going to go into a section view here so that we can kind of get a better idea. So this is what we're making. We have these ports that kind of go through here. we have a very interesting shape on the front, kind of coming back like that. So it's really kind of curvy and organic looking. And I want to start with the outside. Let's take a look at the back plot for now. What we're doing here is we are cutting in this particular diameter with a B-axis contour to give it a little bit more wiggle. And what we'll notice is right here at the beginning of the cut, as I step this in, this is actually respecting the stock boundary because you can see how it switched to this feed movement here. And it's feeding down, and it's going to get down to basically where the chain starts, and then it's going to move on from there and continue. But this really isn't what I'm looking for, right? If I'm trying to cut this lead into the thread, I really want to start from down here. But the reason it's not doing that is because of where it sees the stock. So we need to adjust the stock in order to make it cut the way that I expect it to. So let's go into the parameters. And I'm going to hover over the side until I can see my stock tab. And then we have an adjust stock button. When I click that, it's going to bring me this view here. And this is really similar to what we've seen in standard lathe toolpaths. But you know, this just is how we add it in for the B-axis turning. So I'm going to start by adjusting the entry here. I'm going to click on the green, and then I can move it around. I can set it anywhere I like, but if you look closely, there's 3 little white dots, and those are pre-position points based on the geometry. So this point here, and then we have this one, so that's the end of the chain and just moved straight out in Z. Or we have this point here, this is a tangential extension. So I'm going to use that tangential extension for the beginning. And then for the end, I'm just going to move this one straight out like this. And I think that that's going to look really good. So once we're done, we hit enter, green check, and regenerate. This one will go fairly quickly because it's not too complex of a toolpath. And so we'll take a look at this. Make sure we go back to a top view. And as I step through, we'll see that the tool is now coming in here because it sees that stock was extended down, and it cuts upwards and finishes that profile as expected. And really for this, I mean, we're not even really moving the B-axis. Maybe we could, you know, adjust this. We could change the way that the vectors are working, but I think that this is fine. Being able to just adjust the stock like that makes something like that very easy to do. So another thing, though, that we might want to take a look at, if we're in here, let's see. Oh yeah, let's see. What I'm going to do is I'm now going to add in the face groove right here because we can hit the same thing with this tool, right? So let's go into our geometry. And I'm going to look at this profile. I'm going to right click and edit. I'm going to take the start point and just kind of move it back, just like that. So I'm going to include that groove and regenerate this. And we'll take a look at the back plot. So now, as we're coming in, this is looking okay. And then it's going to come up like this. But then from here, I really don't like the way that this is engaging. I think that this angle's not quite what I'm looking for, and I really want it to not use this portion of the insert over here. I basically want it to think you can only cut on this face. So we can do that by adjusting the usable area of the insert. Let's go back into those parameters. We're going to go to the Advanced Motion Control page. And then here, under Maximum Insert Depth, we can manually set a depth here by putting in a number, or we can click this manual radio button, click on Edit Depth, and what this will do is it will bring up our tool on screen. And we can adjust the usable area by moving these dots around. I'm going to adjust mine so that it's basically only allowed to use about that much of it, like that. I think that looks pretty good. Let's green check there, or enter. And we can also click this preview button. This will give us a little bit more clear outline. So this basically shows where it's treating this as here's the insert that's usable and here's the holder. The rest of the insert's basically gone because it doesn't see the ability to actually calculate the toolpath from that point or from that geometry. So with that, let's go ahead and green check and regenerate that. So running this back into backplot, we can see that now this is going to rotate that tool up much more readily because it does not want to contact on that other side of the insert where I told it not to. What's really cool about this is that if I'm using the same tool for multiple operations, that limitation of the usable insert is per operation. It's not going to override the entire tool. So it's not necessarily changing like the base of the tool definition. It's really just how that operation is going to be affected.
That's such a great update too, because now we're not having to mess around with a bunch of tool axis control lines trying to get that motion that you're looking to hit the side of the insert you want.
Right.
So it's really cool feature that was added in.
Absolutely. Now, the last thing I want to talk about is the new tool axis control method. Much like Jeff just said, sometimes we don't want to deal with that, but other times that's really the way to do it. I'm going to reload this file because it actually is faster to do it that way than to regenerate this toolpath. And we're going to go back into our planes and turn that section view on. Looks good. Okay, so let's take a look at this operation down here. So when I backplot this, the motion here is okay, but it's not ideal. There's some things about this I don't really like. First, the way that really this engages. I don't like this, but I don't want to say, oh, don't use this side of the insert because I definitely want this side of the insert for the rest of the cut, right? So limiting the insert is not necessarily the right answer here. But I don't like the way that this is engaged. It's just not right. Now this tool motion was determined based on the automatic mode for B-axis contour. So everything here is like workable. It's all technically correct. It doesn't make it right. And it doesn't mean it's what I want. So how do we change it? Well, you could manually create a bunch of wireframe that intersects the profile and use that to determine your vector. Or in 2024, we now have the new option for modified. So under the tool axis control page, which is under basic motion control, we now have the modified option. So this is only available after we generate the toolpath as automatic first, then come back and change it to modified. We can then click on this button to edit the vectors. This is actually going to show us on screen where the vectors are that are determining this toolpath. And we can modify these vectors or add to them. So I'm going to change this one, and notice that when I click, the tool profile came up. So by default, it won't necessarily do that. You want to do a shift click to get that to show up. It's just that I've done it enough times to where now it's part of my settings. It just comes up. And I'm going to adjust this, and we're going to set this to like, I don't know, 55 degrees. But if we try to move this too far, notice that the profile here turns red and the tool will not move any farther. So it's noticing a collision here. At this vector, when we try to do this rotation, we have a collision, so it won't let us do it. Same if we go this way. Notice that it turns red here. So this is not hitting a collision necessarily, although I think in this case it was, but it will also turn red if you are beyond the limits of the rotation of the machine. So if you're trying to push it too far, it won't let you do it. So let's see, I think I said 55 degrees. We'll do it like that. And I kind of want another vector somewhere around here. So I can just double click on that profile and that will pop up a new vector that's normal to that, as if it was a surface, or perpendicular to this chain basically. And I think maybe something like this would work. I think that'd be pretty good. And then this one here, I need to adjust this because it's definitely not going to work for me. Let's see here. We'll go something like that, maybe. That might work. And then once we're okay, we can just hit enter and green check, and then you can regenerate. Now, while this is working, we can talk about the next thing, because this could take a second to generate. So I think we may as well bring up our next item and talk about that. Jeff, anything in the chat?
Oh, just a comment about hoping that this will be recorded so they can go watch again. This session is being recorded, and the chat has the URL to the videos page where the presentation will be uploaded to sometime in the next couple of weeks after the recording's been made.
Yep. And in case you don't get that URL, just head to our website, mcamnw.com. Come on over to training and support, and you'll find videos here as a group. You can click on that, and then you'll find all the recordings of our webinars here. And they're loading in slowly. I think my internet's probably a little taxed from what else I'm trying to do here.
Yeah, we have a question also about how do we get the section view? So you pull up the Planes Manager and show how to apply a section?
In a moment.
Once we're done regenning?
Once it's done regenning. My understanding is that the B-axis contour is a single threaded toolpath. And you know what? I think, let's see here. Yeah, Keith is here. Keith can let me know if I'm wrong, but I'm pretty sure that the B-axis contour is a single threaded toolpath. So it does take some time because there's a lot of processing that needs to happen in the background to actually make all that work. So it can take a second, especially when you're doing something that's this is a fairly complex profile. But yes, absolutely. We'll talk about that section view as soon as this is done. And I was going to talk about the next thing, but it's also kind of a complex topic, and I want to make sure that we have full attention on that. Okay. So here we go. We've regenerated, and there is a bit of a problem with this, and that's my fault. It's not because the toolpath did this incorrectly. It's because I was too aggressive with the way that I'm reshaping this vector. So it's having to move the toolpath back out because it's avoiding a collision here. So really it's doing exactly what it's supposed to. I'm the one who did a poor job of setting this correctly. But what we do get is once we're down to this section, you can see how that angle is much better. That's a much nicer vector for that kind of cut. And then we continue on as needed. So that's how you modify that. Okay. Excellent. So that's the B-axis contour and the new ability to use the modified option. I do think that personally, I'm probably going to run everything on automatic, and then if it needs a change, I'll probably try modified before going through all the trouble of manual, because manual is a lot of work to set up all of those pieces of wireframe, making sure they're perfect. They can't ever touch each other. I mean, I get it. That's where we had to start in order to get this to work. But unless you have a really specific circumstance where you want extreme manual control over your vector, I don't think it's necessary. The option for automatic and then modified if needed, I think that's good to get everything that we really need out of this toolpath in 95% of circumstances.
Yeah, much more efficient too, I think. So that's, for me, I have not worked on any B-axis head machines, but I can tell if I were to program one, I wouldn't want to be doing a bunch of manual tool axis lines. So it's an awesome update. Oh yeah, Keith says we can convert from manual to modified too. Oh, that's awesome.
Oh, cool. I did not know that.
So rather than putting a porcupine of lines in there, if you start with a few axis control lines, then we can modify from there. Oh, that is so cool.
Oh, see, now I might backtrack on what I said before. If I can have a few and then add more later, I might do that. I'll have to play with it. I'll let you know. I'll let you know what I find. We'll we'll do some testing, and then maybe down the line, if we do like a B-axis, if we're doing some kind of B-axis mill turn webinar, maybe we'll cover that. That would be kind of cool.
Yeah, that's neat.
And this next one's pretty big, especially if you are a shop that does a lot of hole making. And this is called process hole. Now, we did briefly go over this in our top 10 presentation last month. We're going to get a little bit more into it today. I want to show you some more specific examples. I also want to give you guys a file called 2024 Process Hole Template. Now, I want to be clear. This file is not necessarily ready for prime time. It doesn't have every drill operation done. It's got a few examples and some solids that you can use to help you build out your own library. It's a starting point, but you'll see how we use that pretty soon here. So the idea of process hole in general is if you are making the same hole over and over and over again, rather than programming them over and over again, you can create a process, and that process can simply be applied to a hole that has solid history. And as long as it has solid history and matches the process that you have preset, it can apply that toolpath for you basically automatically. And not just a toolpath, but sets of toolpaths. And that's the big difference. If you have 4 or 5 operations that all have to happen for a hole, you don't have to program that hole 5 times. You can use process hole once and get all of those operations done at the same time. So it's really cool. I think that this is a serious step up from any other hole making automation that we've had in Mastercam. And it really gives us more flexibility and the ability to do everything based on solids, which is huge because, solids is the standard. Wireframe's useful, it's got its uses, but it's not what we program off of because solids have associativity, wireframe really doesn't. So let's take a look at Mastercam and see how this is applied. Okay, now if you were here for our last presentation where we did our top 10, you'll recognize this part. We're going to do things a little bit differently today. But first, let's talk about how we can apply this. Then we're going to look at how we create processes and where those are stored and how to manage those. Then we'll come back in and we'll apply again with new features added in. Okay. So first up, let's go to process hole. And the first thing I want to do is cut in these counterbore holes. These are quarter 20 socket head cap screw counterbore holes. And so I'm just going to control click, and that will select all of the matching holes that are in that vector. Actually, it's not necessarily that. It's from the same operation. So if you had 2 operations that had the same hole, but maybe they were different depths or something, then they wouldn't select at the same time. But here I'm selecting all 4 of these. Now there are a couple of more over here, but because those are part of a different operation, they're not selected. So let's start with just these 4. I've selected all 4 of those. And then down here we have options for sorting. We can sort by tool, which is going to be most efficient for this 3-axis setup. We have by hole, so that's going to do every hole in order with all tools. So if there's 3 tools, it's going to use all 3 tools in one hole, then go to the next hole and process. This is a lot more tool change time, but if you have specific requirements for tool change out, or maybe you can only get through one hole and then your tool's toast, you got to replace it. Maybe that's a better way to do it. And then you have all tools in plane or all holes in plane. So then that means if you're working in multi-axis, which this does support, then you have further sorting by doing it, by plane rather than by individual hole. There's also an option for avoidance. So if you do have anything to avoid, just add it in here. Next, we need to select a process. And for this, I'm going to use my library option here. And I'm going to open my process hole template. And where I have this located actually is not there. It is under my shared folder. Here it is. And then I have added a new folder called processes. Yes, you can add folders to your shared Mastercam folder here. In fact, I have 2. I have one for processes and I have one for fixtures. And this is really nice because if you have multiple programmers that are all working off of the same shared folder, create folders like this, like a fixtures folder, a processes folder that everyone can access. And that way everyone's playing with the same tools. So under processes, I put my whole template here. And once that's been selected, what it does is it looks at the solid and it looks at the history and it decides, do I have an operation from this template file that matches the geometry that I've selected here? If so, what operations are available? And here I have one option, this 1/4" socket head cap screw through with chamfer. And it gives me these 3 operations. So that's kind of all it really needs is to know what that is. We'll get into how to build those in a second. And then we have the linking. Here we can switch between minimum height or a clearance plane. There is a safety zone option, which is what happens when we use multi-axis. So we'll get there in a second. With the method for linking, it's personal preference or whatever you need for your part. I'm going to just say, minimum, call it 0.1 and 0.1. So with that done, we have one process hole operation, and we can see that it has come in here, drilled, helix bored, and countersunk for that chamfer. So if I run this in backplot, we can see the drill, helix bore, and then the chamfer. Easy peasy. And so what I love about this is it makes it really easy for us to add multiple toolpaths to a part quickly. In fact, if I wanted to add this in, let's say we're on a 5-axis machine, I can do that. Control click here, add in those holes as well, which it will only let me add them if they have the same properties. So they're both of these sets of holes are basically identical in that they're all through holes, they're all the same diameters for each of the different steps, and they each have, a chamfer that's the same size. I can add that in, and there we go. Now I've got a 5-axis version of this. I will say that in the linking, this automatically will switch to safety zone, sets itself to rectangular. I have been doing some playing around with this, and I've noticed that if I use bounding box and try to set this to wrap, my results have not been as good. I've actually been relying on rectangular, and that seems to do a really good job. So I'd say, maybe we'll try it again after the next update, but for now, the wrap is not my favorite. I really prefer the rectangular. Now, if I wanted to add in these holes down here, we could try that. We'll go to process hole, and I'll select the holes. I'm going to control click, and there's 3 different depths of holes. So there's 3 different pieces of solid history to define those. So I'll click them all like this. They can have different depths as blind holes. That's okay. And we'll notice here, it's already pulled up the template, but it can't find any operations that will work for this. So this is where we need to open up our template file. So this is the file that I sent out to everyone else through the handouts. And this is a template file where you can go in and build the operations that you think you'll need for your hole making. So here, for instance, we can see we have our 1/4" socket head cap screw through with chamfer. And so down here, I have one hole that was defined that way. And then I created toolpaths that work with it. It's important to note that the history is very specific. So if I open this up, everything about this whole definition needs to match exactly to the part that I'm going to cut, except if it is a distance on the depth instead of a through all, this number can change. That's fine, but everything else must match. Even if you're running on through all, the bottom angle also has to match. That's important. We have to note that. So at this point, what I want to do is add in that set of holes that we saw on our other part. So I'm going to go back to it really quick, just so I can get some information on the hole. So I have 3 sets of holes. They're all marked as 136 simple. Okay, so these are a 136 diameter, and they have a 10,000th chamfer, and their depths are, something. And all 3 of these are going to be exactly the same. I know how they come in because I have some experience with the file. But something else to note here is, what if your parts come in without any history because they're from a different software? Maybe you get them from engineering in SolidWorks. In that case, what you'll want to do is go to model prep and use find holes. And when you do that, you can find the hole histories and you can make them match anything you want specifically in Mastercam. So, let's actually do a quick, let's do something quick for that actually. Well, no, we're not going to do that, but what you can do is when you do the find holes, you can set it to specific templates. There's a templates drop down right here where you can select different types of holes, and you can even create your own categories. And in this case, I want these to actually be 830 seconds or whatever, right? So, I can go to UNC and then I go down here to 832. So, based on the print that I have, this is the actual thing that I'm looking for, right? But in this case, the depth on this one's only going to be 0.6 for the first one. And then on the second one, same thing. I'm going to use the UNC 832. But this one's going to be 775. And then this one here is also going to be UNC 832. But this one will be 0.9. And you can also, change the names of these if you like. But now that those are sitting just like that, I know that they match a specific definition of a hole in Mastercam. I'm going to go ahead and save that, and then we're going to go to our template so that we can take a look at how to add this in. So what I might do here is, I don't really see a group here for a tap drill that has a chamfer on it, so I'm going to add that. So what I'm going to do is I'm going to take this block, go to dynamic, snap it here, set this to copy, and bring that down just like that. Then I just need to find which one that is. Here we go. It's this one. So I might change the name of this. We'll say, actually, you know what? This is a blind hole, isn't it? So we actually need to go to the blind group in this case. So sorry, we'll do that one more time. So I'm going to go here. We're going to copy that down 3 inches, just like that. Perfect. I'm going to look at my blind group here. That's the one. So we're going to rename this to tap with chamfer blind. Then I'll take a look at this first hole, and all I'm going to do is make sure that this matches exactly to what my part was, right? And the idea here is that I'm building a template to use for all of my future parts. So as my parts come in from engineering, anything that I see on the print is an 832, I'll just add this definition to it. So here, the depth is not going to matter as long as it's set to a distance rather than through all. That's the only thing that has to match here. But everything else from the template will pull in identical. The diameter and the chamfer information, all that stuff. And once that's been created, we can see it there, I can add a new toolpath group that will define our new process. So I'll right click here, group, new toolpath group, and we'll call this 832 blind with chamfer. Then we add our toolpath here. I'm going to make sure that I select the entire hole. So I double click it and I get this name here rather than solid face or arc or something like that. Then we'll go ahead and select our tools. So maybe we'll spot this first. We'll set it up as a simple counterboard hole, simple drill. And we're going to calculate this one from the top. And this will end up being a finished diameter of, let's say 0.1 for a 136 hole. All right, run that through backplot, make sure that looks good. Ooh, that's a bit aggressive. Let's take a look at the whole sections or segments. See, we got all 3. Interesting. Let's see here. Is running. way too far for some reason. And this is me screwing up here. This is not because Mastercam can't do it. I am doing something incorrectly here. Oh, tip comp, doy. That's the one. And we're going to go over that linking page a little bit more, I think, tomorrow. There we go. Looks good. So then I can take this. I'm just going to copy and paste it down. We're going to switch this to the correct size drill. So in this case, this is a 136 hole. Find a 136. Looks good. And this time we'll undo this and set this to 0. And because it's a blind hole, we're just going to leave it like that. I think that'll give us a nice result. And then you can follow this up with a tap. So we'll go here and we'll select the correct tap, which is going to be an 832. And then under cut parameters, switch this to tap or rigid tap, depending on what your machine needs. And I'm just going to keep this a little bit shy of the bottom of the hole, say 100 thousandths. So at this point, I've now added in the process that I would use for that particular type of hole. I'm just going to save that, and we're going to go back to the part. So this does take some initial setup work, right? I mean, this isn't totally free, but now every time I do an 832 hole, it's ready to go. I can pick on process hole, control click all of those. I'm going to reload my template here. And something didn't pick up, and I don't know what. So let's see. I'm going to go into my solid definition here. Let's see where it says a distance. And this is kind of the trick of process hole, honestly. It's when you're using it, it is extremely picky about how everything is going to work. So it does take a good amount of setup to do. But once it's there, it's really good. I think for today, we're really kind of running shy on time, so I'm not going to continue this right now. But what we are going to do is I'm going to build a pretty long video that's going to go on our knowledge base. Jeff, I don't know if you want to get a link for our top level, the knowledge base going.
Sure. Also a question about maybe the chamfer size as the
could be
culprit here.
Yeah, could be. I mean, I pulled it from a template. So let's see, 039. Let's go back to our process hole. And we'll go to the solid. Yeah, it's still pulled from there. So, I mean, that seems right. The other thing I've been checking is bottom angle. Even when it's set to through all, that angle is important. But yeah, they're both blind. Not entirely sure why it's having a problem. But in any case, what I wanted to mention was the knowledge base. And so if I open this up, this is something that's kind of new for us. Over the last month, you may have noticed if you've put in some support or anything like that, our support's a little bit different now. And that's because we switched to a new system that allows us to address our support more efficiently. But it also allowed us to create this knowledge base. And so now you have the ability to come in here and just check out stuff that we've been able to post about. So right now, a lot of this is very technical and, support based. But we are going to be adding in lots of videos that are really just kind of training for how to do various things in Mastercam. So the first one that I want to do is on process hole. I'm going to make a video on process hole that goes over this step by step from beginning to end to show you exactly how to set it up. And so that's hopefully coming out in the next few weeks. But yeah, I would say keep an eye on our knowledge base. It's going to grow. It's going to become a great place to go for all the information you really need about Mastercam. All right, we only have a couple things left to cover here, but we are getting a little short on time. So the next thing is to look up machining angle controls. So this is for the unified option or the unified tool path inside of Mastercam. When you are, using the plane method here, your machining angles page has this field for changing the machining angle. And this is supported for all of these options here, your WCS options, construction plane, or tool plane, or custom angles. So whenever you're set to any of those types, that is available to you so you can change the machining angle. The other thing to talk about is the option for straightening cuts on boundaries. So this is going to be pretty similar to extend edge curve, which we saw in, I think that was Morph. But this works slightly differently, and it's going to be really great for Unified. So let's go check that out. So taking a look at this toolpath here, we're using a Unified toolpath, and we are guiding this in the cut pattern. We have one guide curve, and that's the blue one that's down there. And this is okay, but we notice that there's actually some issues here. Notice that because the guide curve ends at that point, the toolpath really kind of wraps around because it's trying to follow that guide curve. And this creates some really weird toolpath intersections, and it's really not desirable for our finish. We want this to be a lot smoother and more flowing. So if we go back into the parameters, actually what I want to do is I want to copy paste this so that we can go back and forth. So in the copied version, we're going to go to the cut parameters subgroup, machining geometries, advanced parameters, and we're going to turn on straighten cuts on boundaries. Now, when we turn this on, it will automatically turn on fill holes, but it also brings you a new checkbox for no cuts in holes. Because we have a few holes here, I'm going to go ahead and turn that on because I don't see a need to cut them. Go ahead and green check to regenerate. And now we have a different version of this. I'm going to go to my view, and I'm just temporarily, I'm going to turn off my rapids. And we can see how much smoother this is for a toolpath. We still have the toolpath kind of changing its angle on this end because the end of this curve that we're using to guide it does drop off this way. So it's just taking that and extending it tangentially. But it gives our cut motion a really nice look to it. And then on the other side, we see kind of the same, except for this is pretty straight. So here, all of our cut motion is very straight. So I just think that looks really awesome. Again, it's a little checkbox you can click to just get, much different motion out of your toolpath. I think that's pretty cool. All right, next up is, let's see, setting first/last leads for 3D high-speed finishing toolpaths. It's a lot of words. So the linking parameters for 3D toolpaths have a new subgroup here for first and last leads. And this allows you to change the lead motion for the first and last pass in the toolpath. So this is getting more into kind of what multi-axis does right now, where you have more options for how to break up your lead motion depending on where you are in the toolpath. So we're just kind of adding a little bit more of that to the 3D HST groups. And here, if we take a look at our toolpath, the first place that we're going to come in on this toolpath has us coming in with this vertical arc, which is okay. I'd kind of prefer a horizontal one for something like this. And then it's going to continue to move around. It's going to break up the toolpath in a few places. Notice that as I move from this pocket here, and we move up, so we're almost there. We move up, and we're going to move into this next one. This vertical arc, I actually kind of like the vertical arc here. I think that's nice. And for the most of this part, I really do want that vertical, just not at the beginning. Also, the ends of the toolpaths, horizontal works really well, but not for the very last exit. If we take a look here, because of the limitations that we have with this particular area, a horizontal exit really doesn't do very well for us. It basically just flattens out and does nothing. So that's not ideal. So that's where first and last leads come into play. We go into the subgroup underneath the linking parameters to turn these on. And I think what I want is I'm going to turn off the secondary for the lead in. We'll just have this at horizontal with a radius of, let's say, 2 instead of 5. And I think we'll leave the lead out as it is for now. Let's see how that looks. Okay, so now here's my lead in, and that looks really nice. That's exactly what I was looking for. And then the lead out, it looks like that might not be perfect because it's kind of straightened it out. So it's probably because the radius is too big. So we'll try bringing this down a little bit. We'll try 2 and 2, and I'll just use my apply button so we can kind of play with this as we go.
Yeah, and John, once you find motion you like, could you go ahead and backplot that as well so we have a better visual representation with the
Sure. Oh, this is set to
streaming
horizontal.
compression.
Right. So I also had that set to horizontal, which is not what I wanted. I wanted this as vertical. Hey, that looks way better. Okay, so now let's take a look at this in backplot. So now, when we're making our motion on the first in pass, we have this nice radius motion coming in. That looks way better. And then at the end of the toolpath, as we're coming out here, let's see, we have one pass left. We're going to radius vertical on our way out, nicely clearing the part before we wrap it out. And that looks really nice. So that's basically exactly what I'm looking for out of this toolpath. And you know, you don't have to use it. You can keep it turned off if you like. Just giving you more flexibility in how you want to apply your toolpath. All right, let's see. Next up is going to be maximizing your tool engagement. So this is a new feature for dynamic mill, dynamic option within the face toolpath, and the dynamic OptiRough toolpath. This is a checkbox that you will find in the cut parameters tab. If you're doing facing, you'll find it here. And then if you're doing dynamic mill or OptiRough, you'll find it just within the step over group, a slightly different position. And what it does is it changes the way that it looks at the step over for dynamic, because it will be more aggressive with how it brings that tool in to the motion. So this tool, this picture doesn't give a great example. So let's bring up a different example that does give us a better idea. So on this part, I'm using dynamic mill to come in and face off the rest of the material at those particular features. So we're basically assuming that, you know, some roughing has happened and we just have a bit of material left on the face. So from a top view, this is the original dynamic toolpath that we all know and love, and it does a good job, but there are a couple of areas where it's not perfect. Let's take a look at this area here for thin wall, for instance. I'm going to put this into backplot, turn off the holder, and use the quick verify. We'll come in here. So here's our first pass. Notice that even though at this point, all it needs is this, which is smaller than the tool, it's limiting how much it steps over and leaving a little strip there for another pass. Then it comes in with a second pass. Move it forward a little bit. Oh, there we go. Okay, so then it's going to come in here. And as this tool is engaging, the amount of overlap between the tool and the side is very little, very minimal, right? That's not ideal. We could do a bit better. And notice that it's doing this like extra little whip around to come in and grab that. And then it's going to come and get what's left of this island over here. As it's doing that little island, it's going to loop around a few times to cut that down. And each time it's really, you know, not taking as much of the tool as it could into that cut. What you end up with is on this kind of last pass, you can end up with a little ridge or ribbon of material here that, you know, according to the verify, it's been cut, and it has been, but material may push a little bit and cause these little ridges when you don't have a lot of overlap with your tool. So that is what maximize engagement fixes. When we turn that on, notice that there's a significant difference between the two. The amount of toolpath is also reduced, 864K down to 761. So it's less toolpath. If we take a look at the same area in backplot, we will see a difference in how this engages. So it's still respecting the step over that we told it, but it is going to get to that step over as aggressively as possible. So here we can see that it's going to do a lot more in that pass. And then as it comes up here, look at the overlap difference with this inner wall. It's much better than we had on the last one. And then finally, when it comes up to do this last bit here, which I'm just stepping through here, it's going to be a lot more aggressive here. So not nearly as many passes to get around. It's going to go up, spin around as soon as it can, and then get a lot of overlap on that final bit. So again, turning this on is as simple as a checkbox. Undercut parameters, we find it right here for both dynamic mill and OptiRough, and then you'll find it in a slightly different spot for facing under dynamic.
And that actually did reduce the amount of code by 12%. So also a nice efficiency gain there.
Indeed. In fact, if we take a look at these, I believe everything's all set. Yeah. So if I put the first one into verify, we're looking at 2 minutes and 48 seconds, right? And then the second one is down to 2 minutes and 28 seconds. So we're saving, what, 20 seconds? 20 seconds per part. And that doesn't sound like a lot, but when your total cycle time is less than 3 minutes, that's pretty good, right? So, I mean, it can make a difference in terms of cycle time. And it does do a better job of getting that overlap so that you can prevent ridges when you're doing face type motion. Now, this will beg the question, why wouldn't you want this then? Why is it a checkbox? Why is it an option? Why is it not on by default? There are situations where you don't want this. This will come up if you are running really difficult material. You might have some material that if you tried to engage it too quickly, it would just break your tool immediately. In that case, you may not want to turn this on. And also, if you're in a situation where your material isn't necessarily consistent, or you don't feel consistent, you don't feel like you can trust it to be consistent. Let's say you get your material coming off of a bandsaw and you know that that bandsaw is not very good. It is very old. They do not replace those blades often enough, and it's all kinds of nasty, right? You've been there, you know what that's like. In that case, I would feel a little more cautious about using something like this. Or what you could do is, you could be in a situation like this, where if you were making this part, maybe I wouldn't use that for, say, the first go around to get the profile done, but I might use it later. Or I might, set up one operation where, I leave a good amount of stock on the walls for the first op, not using the option, and then come back with a second operation that doesn't leave any stock or very little, but does use the option. So you do have flexibility in how you might want to implement this, but there are some times where you might want to be a little cautious. Overall, I'd say that a lot of people could probably go ahead and use this on a regular basis. I'm back to this part just so I can show you another tool here. So if I go to my drafting tab, I should probably tell you what we're doing. Okay, so the next one is called modifying your drafting dimensions directly. So in this update, basically the drafting page looks quite a bit different. There is a significant change to the way that this looks in its panel interface. We now have side tabs, and these give you access to basically anything that you would set within your configuration. And what's nice about this is it allows you to change certain things that otherwise would have been kind of locked down or difficult to get to. So let's use, let's see, I'm going to use a circular dimension, and I'm going to get a circular dimension off of here and bring it out. All right. So here with this new panel interface, I have options for changing the text. I can change the tolerance style. So instead of being locked to this, I can switch this to plus or minus. And that's something that I would have to go into the config to do before. And now I can do it right here. And this gives me the option to just draw in what I need right here, and it'll show up out here. I think you also get options to, or the ability to change things like here's your symbols. You can change these as well. You can change your scaling, your orientation, your leaders and witness information is all based here, and you don't have to get all the way into your config to do it. So this is a really awesome change. I really prefer this over what we had before. It's important to note the way that this works. When you open Mastercam and you open drafting, it's going to load everything you have in the config first. Then you can come in here and you can make your changes. If you do another drafting entity, it's going to pull in whatever information you have in this panel. So it's kind of like a second layer of configuration that's temporary. It sits on top. That's going to continue to be used until you completely shut down Mastercam and reopen it. Then it will reload the config information. So with that said, there are two updates that they would like to make to this, or that have been requested. One of which is the ability to save changes to config from these panels, and the other being the ability to load from config here without having to shut Mastercam down. So if you agree with those ideas, make sure that you go over to the mastercam.com forum and post about it, or find another post and do a +1 on that. It really helps Mastercam understand what things to change first, because more people are looking for it. And you can, you can say that about anything. I'm just saying, if you agree with this particular one, you should definitely do it. And I think that we are at our last one for the day, which is going to be machining flat areas with area roughing. So this update is for area roughing, and essentially this is just adding critical depths as an option for area roughing. So if you're familiar with Waterline, then you've already used a tool like this, most likely. By turning on a checkbox, you now get the option to either go to specific depths that you mark, or automatically detect any flat and make sure that that gets machined with area roughing. So let's take a look at that example and see how that works. Here we're taking a look at this part that has area roughing. And when you're doing area roughing, if you're not familiar with this toolpath, the way that this works is it works on a pure step down method. It's looking at where you're starting from the top and then making cuts downwards. And in this case, our step down is 0.2. So it will make a first cut at 0.2. And when it goes to make the next cut, it's basically just looking at, hey, is anything in my way? If it is, it will not cut another step down at that area. It'll just ignore it and move on to the next area. So that means you would get a result that looks kind of like this. And if I go to my View tab, Material, here we go. You get all of this extra material on top. We're not anywhere close to actually hitting the depths on a lot of these features. So that's where the critical depths comes in. If we open the parameters here, under cut parameters, when you turn on critical depths, you have the option of either include flats or include manual. So this is set for include flats. And with flats, what it will do is it will automatically add cuts at any flat that it sees. So this does a really good job of actually getting down to all of the floors. This is also the longest way to run this toolpath because it has the most to hit. So it's kind of, what do you want to do with it? What do you expect out of your toolpath? We don't have to do anything other than turn this checkbox on and use include flats to get this change. The last toolpath down here is using the include manual option instead. This means that you have to pick the points in Z that you want to hit with this toolpath. So in this case, the way that those were picked, the pockets here were all chosen, but the floors here, here, and here were actually just here and here were not chosen. This one was. So this gives you a little bit more of or kind of a hybrid approach where you can only finish floors where you want to and leave other ones with extra material. So it gives you that flexibility back. That's really the last thing that I had to talk about for today's webinar. However, we do have another one scheduled for 2 weeks from now, where we're going to go over even more new features for Mastercam 2024.